Hello, we're doing the food dye project using G10, and our group consists of Group A, which is Jacob and Ziran, and Group B, which consists of Bill and myself, Diego. Today is October 5th, 2022. Our TA is Daniel Chavez, and we're in CHEM 151, Lab Section 3A. So our project goals for this project was to use spectrometer to quantify how much mass is in 500 milliliter servings of a given mystery dye. For us, it was G10. So we had to figure out what dyes were in there and how much of that dye, of each dye, was in this mixture. And ultimately, we have to find out which of the mystery dyes in our class has the least amount of dye present in it.
Okay, so when it comes to identifying which dyes were in our assigned drink, we put a sample of G10 into the spectrometer and we found two peaks. The first peak is for yellow 6, that is around 428 nanometers, and then our second peak is what we identified as blue 1 to be at 628 nanometers. So this is our Excel calibration. This is the concentration and the absorbance. So for the first point, we did 0.55, and then we continued to just add more and more stock to it until the final one, which is about 3.44. So how we got our calculations, or how we did our calculations. So for the step 1 is that we plugged our absorbance and the epsilon that we calculated into the concentration equals absorption over epsilon b in order to, so for blue 1, we got the concentration equals 0.291 over 1.5 times 10 to the 5th, and that got us 1.94 times 10 to the negative 6 moles per liter. And then for yellow 6, we got concentration equals 0.731 divided by 2.6 times 10 to the 4th, and that equals 2.8 times 10 to the negative 5th moles per liter. Then for the second step, we take the concentration and multiply it by how many grams per mole there is for the respective dye. And so for blue 1, we did 1.94 times 10 to the negative 6 moles per liter times 792.85 grams per mole, and then that equaled 1.54 times 10 to the negative 3rd grams per liters. And then for yellow 6, we did 2.8 times 10 to the negative 5th moles per liter times 452.37 grams per mole, and that got us 1.27 times 10 to the negative 2nd grams per liter. And then for step 3, we took the number that we just calculated and multiplied it by 0.5. So for blue 1, we did 1.54 times 10 to the negative 3rd grams per liters times 0.5, and we got 7.7 times 10 to the negative 4th grams. And yellow 6, we did 1.27 times 10 to the negative 2 grams per liters times 0.5, and we got 6.5 times 10 to the negative 3rd grams. And then here is just that work, all that work we just did, put into the tables, along with the wavelength, maximum absorbance, and the absorbance and molar absorptivity.
All right, so our group did the similar steps to Group A. So we also took the mystery liquid and we put it in the spectrometer, and using that we did identify two peaks. And these two peaks were around 632 nanometers and 46 nanometers. And these roughly correspond to yellow dye number 6 at 632 and blue dye number 1 at 486 nanometers. And those were the max absorbance of those two dyes. And so basically what we did next is that we took 5 different concentrations of each different dye, and we have basically put them each in a spectrometer to determine what their absorbance value was. So first we started off by finding the absorbance value of a pure dye, which was about pure dye, and the concentration of that was around 4 times 10 to the power negative 5 moles per liter. And then what we did was that we basically we would essentially divide. We basically altered the concentration, reduced it by orders of 1/5. So the least concentrated was about 1/5 the regular concentration of pure dye. The second dye was about 2/5 the concentration, and so on and so forth. And doing this, we got 5 different concentrations. And through doing this, we were able to plot and finding the concentrations, the absorption values of different concentrations. We were able to find the slope of the dyes, and And this is important because according to Beer's law, the absorbance value of a liquid is equal to its concentration times the distance that light travels through the container the liquid is in, and the molar absorptivity of that liquid. So because our containers, the cuvettes, were all about 1 centimeter in size, it was held constant. And because by changing concentration, we were able to find the slope, which was the molar absorptivity. And we did this twice for both dyes, and we got a total of 4 different results. So once we found the molar absorptivity, we could use that to determine the concentration of each each dye in the mystery liquid. And so as I just said before, Beer's law says that absorptivity is equal to distance that light travels through the container times molar absorptivity times concentration. And we do some algebra that imply that concentration is equal to absorbance divided by molar absorptivity and the distance that light travels. So all we had to do was just do that. So we took the absorbance values we found at those peaks, and they were about 0.2974 for blue number 1 and 0.745 for the yellow number 6. We divided that by the molar absorptivity we found, and we found the concentration of the mystery dye in our samples. So once we did that, we just multiplied that by the grams per moles indicated on the container of each dye, and by doing that, we were able to find the grams per liter. So for blue number 1, we found it was about 1.68 times 10 to the negative 3rd grams per liter. And for yellow number 6, it was about 1.394 times 10 to the negative 2 grams per liter. And this was because blue number 1 had a much lower concentration than yellow number 6. Once we did that, we essentially just divide each value by 2 to get the concentration for 500 milliliter, so the number of grams per half a liter. And then doing that, we found the result was 8.34 times 10 to the negative 4 grams per 500 milliliters for blue number 1, and 6.97 for 10 to the negative times 10 to the negative 3 grams per 500 milliliters for yellow number 6. And this is the results in our table. So this is the maximum wavelengths of the dyes by themselves, the absorbance values that we found in our mystery liquid, and molar absorptivity we found from our graphs, and then the concentrations per liter. And then this is the final mass of the dye per 500 milliliters.
So comparing group A and B's results, we saw that our results were pretty similar overall. But if we look even at the wavelengths, we got slightly different wavelengths for each given dye. And therefore that changed our end result by quite a bit. So some reasons we think that our results could have been different from group A is that we could have made a rounding error or just rounded at a different spot than group A. Or we could have also, our spectrometers could have been slightly different and had a different calibration. So that could have messed up what we initially got for wavelength and absorbance. And then what we finally came up with, which is probably, I would say most likely, is that our dilution sets were slightly different. For example, if I was trying to take 5 milliliters, I could have accidentally taken 5.01 milliliters of anything, of the dye or the nanopure water, which could have ultimately changed the concentration that was being calculated and kind of messed up our results a little bit. And for potential improvement, we noticed that our graphs had an R2 value our squared value that wasn't equal to 1. It was pretty close, but if we could have maybe run the experiment a couple more times and used trials that had an R squared closer to 1, that would have been better for determining what the actual concentration was in G10. We could have also run more trials, which kind of corresponds to the last one. And then lastly, we could have tried to prove that our results were correct by mixing the amount of dyes that we expected to be in G10, our mystery drink. So mixing X amount of blue 1 and X amount of yellow 6, mixing those and seeing running them through a spectrometer to see if it's similar or equal to like the graph of G10. So for our class results, this is what we got from other people, and we saw that the mystery dye with the least amount of overall food dye in it was J76, and we did this by adding up just the values of each trial for each drink, and the one with the lowest average ended up being J76.